This is Mark Strassman, reporter with Etopia Media Medical News Network. We're about to speak to Dr. Neil Martin, who is the Vice Chair of the Department of Surgery at UCLA Medical Center and also the Medical Director at the Neurosurgery ICU at the UCLA Medical Center, and a few other things, but we only have a half an hour, so we're not going to go into all of his titles. Welcome to Etopia Media Medical News Network.
Good afternoon. It's great to be with you.
As you can see, we're using the same kind of telepresence and teleconferencing that your RP-6 robots use, and I think that's going to make this particularly interesting to talk about.
You bet. Yeah, it's been extremely useful for us.
Why don't you tell us a little bit about your involvement there in the neurosurgery department and the positions that you hold there and how that relates to you becoming the lead investigator in this RP-6 trial?
Sure. Well, I'm the chief of the neurosurgery division, and a lot of the work that I do it involves managing patients in the intensive care unit. I take care of patients with stroke, with brain injuries, and they tend to have acute medical issues, crises, if you will, anytime, day or night. And so one of the key needs we have is the ability to respond to an emergent event or a crisis in the intensive care unit almost immediately, so that we can get on top of problems rapidly and prevent them from becoming more severe. We've been engaged in extracting and displaying information from the intensive care unit for a number of years. We are able to now get bedside waveforms and the blood pressure and intracranial pressure data, laboratory results, transmitted to us on our desktop computers in our office or at home or really anywhere where we have internet connectivity. And we can also now get that same sort of information on wireless PDAs and cell phones.
So essentially all the information that you'd have if you were standing there in the ICU and looking at all the monitors up on the wall that were measuring blood pressure and pulse and intracerebral levels as well.
That's right. Until we started using this robot, and I'll explain how that helps us in just a second, but until we started using that, we had everything except our ability to virtually be there, talk to the patient, talk to the nurse in a very natural way. The robot allows us now to basically stand vicariously at the bedside through the robot, which can be driven around the intensive care unit, and to talk to the nurse and the patient, to examine the patient through this kind of video conferencing, two-way video conferencing, so that not only can I get the data now, which is transmitted electronically to me, but I can almost be there to manage the crisis in person.
Now, what you see is as good as or better than you'd be able to see if you were there? In other words, what can you do with the camera that lets you zoom in and look very precisely at those things that you want to look at?
Well, what I can see all of the monitoring devices around the bedside, because I've got a high-resolution camera on the top of the robotic head. I can examine the patient from head to foot. And equally important, the patient can see me. And this robot has a body that's about 5.5 feet tall. And the head of the robot is a 15-inch flat panel display. And associated with the head is a camera so that I can see. So the patient sees my face projected on the monitor of the robot as if that were me.
Pretty much life size.
Just about life size, exactly right. And so I can lead the patient through an examination. I can hold out my hands and ask the patient to touch their fingers so that they can see me in the camera and mimic what I'm doing. If I want them to name objects to test their language abilities, then I can hold up various objects, to ask them, what is this, to see how their perception is and how their speech is.
So essentially, you're conducting the same examination, the neurological examination, that you would if you were standing there physically present.
That's right. That's exactly right. And I can respond to questions that the patient might have, or their family might have, or the nurse might have.
How long did it take you to adapt your bedside manner to a remote bedside manner?
Well, I think I get a little better with it every time I do it. I'm learning how to use the field of view of the camera so that they can see everything that I want them to see. I'm learning how to move the robot in a more human way so that there actually is this sense of virtual presence. And it's very interesting to see. When you see the robot at the bedside, the robotic head is turning back and forth, looking at the patient, the nurse, the family, looking from head to foot on the patient. And the patient also sees the robot drive right up to the bedside, as if I were walking up to the bedside. All of these indirect elements of the interaction, I think, have a real impact in making it a more human-like interaction, as if I was there.
So in fact, the visual cues that humans are programmed to understand as care are being replicated through this mechanism.
I couldn't have put it better myself. That's exactly right. That is an important concept. Rather than them just looking at a screen on the wall, or them just looking at a web camera staring at them, they're interacting with an entity that acts in some ways like a human.
And of course, you're able to bring the same expertise and experience that you could being physically present to the virtual encounter, and therefore that probably adds to their comfort level as well.
Right, absolutely.
Okay.
To their comfort level and to the nurse's comfort level. So now we're getting to that dream of being in two places at once, literally.
Okay, well, let's talk about that. How many places at once can you be? How many of these robots are available now in this trial?
Well, right now there is just one robot stationed in the Neurosurgery Intensive Care Unit at UCLA.
Okay. And
we're starting with that. Our plan is next to have a robot in another hospital 7 miles away, where I'm often called to consult on emergency room patients. So there may be another one that we put in the emergency department at Santa Monica Hospital.
Okay. Now, obviously, this is a general purpose medical robot, and we may talk later whether it's even has purposes beyond medicine. But in medical terms, it doesn't have to only be in an ICU. It can be in an emergency room, or it could be used for normal consulting practice if your patient were in Arizona or Malaysia or wherever.
Absolutely right. Now the robot right now is a two-way communication facilitator and a virtual presence avatar, if you will. It doesn't have arms today.
Right.
Someday in the future it will. So I can't actually interact with a patient in a physical way, but the communication is greatly facilitated.
Okay, let's talk a little bit about the trial itself. Who's funding it, and who's paying whom between InTouch and UCLA and more generally?
Sure. Our goal with the research is really to test the reaction of the medical personnel and the patients and their families to this kind of an interaction. We want to know how well it works, how easy it is for the physician to drive the robot and interact with a patient, how useful it is to respond rapidly to a crisis with this form of telecommunication. So we will be querying the caregivers, the doctor on one side of the screen, the nurse on the other side of the connection, the patients as well, to check the effectiveness of the interaction. It's also a technical assessment, so we're going to be looking at the lag times in the interaction, the ease with which you can navigate the robot around the complex environment of the intensive care unit, and the quality of the video connection, the quality of the internet connection. All of these things really have to be assessed to make sure that this is a reliable enough system and an easy enough to use system that it's going to be generally accepted.
Anecdotally, what's been your experience so far?
Well, you know, I have been very, very impressed so far. I have had very few technical failures with the robot. I've driven it throughout my ICU, and on occasion when I have a younger patient, I've driven down to the pediatric intensive care unit. The nurses, there's a very sort of a stereotypical response that people have. Initially, they're amused by it. They're embarrassed by the interaction with this strange-looking thing, and they're a bit self-conscious. But after a minute or 2 minutes or 3 minutes, they start talking face to face with the robot, with my live face on the robot, as if I were standing there, and they get used to it very, very quickly. It's amazing how quickly you're accepted as another legitimate person in the environment.
Right. And again, you know how to behave like a doctor with the nurses and the other doctors and so on, and you're bringing all of that to the interaction through this platform.
Right.
Okay.
Right. Right.
What's the involvement, or is there, with the U.S. Army Medical Research and Material Command?
Yes.
The Telemedicine and Advanced Technology Research Center in Fort Detrick, Maryland?
Yeah.
What's their involvement?
Well, they're very interested in advanced technologies and their appropriate application of medicine in a variety of forms. In the operating room, in the intensive care unit, they're very interested in telemedicine. And we propose to them this evaluation of the interaction between a wireless mobile medical informatics system, what's called the GCQ, or Global CareQuest system. This is an in-house system that our team here at UCLA has developed to facilitate reviewing medical information remotely.
That handles
the interaction.
Yeah, that handles everything except the teleconference aspect.
Right. Right. That lets us look at the laboratory results and look at actually the x-rays, but it doesn't give us the interaction. The robot provides the human interaction. So the marriage between the data and the human interaction is what we are developing for TATRIC, the Telemedicine and Advanced Telecommunications Research Group with the Department of Defense. So they have funded this research project for the next couple of years, and our initial experience has been extremely positive.
Well, let me ask you a slightly detailed question. When you're getting the the teleinformatics, the information on the various things, do you look at the monitors with the camera, or are you also getting another feed through this other system that puts it directly on your screen, so you don't have to actually go look at it? How does that work?
Well, it's certainly possible with the robot to drive up to the bedside monitor and just look at the screen as if you were standing in the ICU. And it's possible to look at an X-ray view box and look at a scan. But we have all that information transmitted electronically to a second screen. So I'm looking at you on the screen that I would use for the robotic interaction now, and right next to that, in a dual screen array, is a second screen where I have a projection of all of the information that applies to the intensive care unit patients.
So you can look at it again with the camera, but you're getting it better and just as fast on the other half of the screen.
Right.
Okay.
Rather than driving from one monitor to an X-ray view box to another computer to look at laboratory results, it's all presented in one integrated, physician-oriented view for us.
Okay. Talk about the economics of this in terms of how being telepresent in the ICU enables you to give a higher standard of care and cut costs and give a better quality of experience to the patients and make it easier on yourself. And,
sure.
And how does the amount of money you're expecting to save going to pay overall for the investment in the machinery?
Mm-hmm. Yeah, those are the key questions that that will be asked before this becomes something widely disseminated. Well, let me talk about the old paradigm without this kind of a system. The old paradigm is I would get paged on a beeper. They'd tell me there's a crisis in the ICU. I would call them on my cell phone, and the nurse would walk away from the patient to talk to me on the phone and tell me what's going on. Now, she wouldn't be able to describe well what the waveforms of the EKG look like or what the x-rays look like, and certainly I had no direct communication with the patient. I couldn't lay my eyes on the patient in that format. So what typically would happen was I would get a brief description of the problem, and then I would drive to the hospital at 2 a.m. in the morning to see what was going on. The situation now is I get that page still, and I walk down to my study, and I log on to the InTouch robot, and I call up the Global CareQuest informatics system, and within 2 minutes of my waking up at 2 a.m., I'm essentially standing in the ICU working with the nurse to deal with the crisis, talking with the patient to find out what's going on.
So that's good both at 2 a.m. So and it's also good at 5 p.m. when, depending on where you live in LA, getting to UCLA can be a nightmare in itself, of course. Okay,
right.
Go ahead.
Yeah, and the other problem, in both paradigms, I show up somehow at the bedside. In the old paradigm, there was a 15 to 30-minute lag time before I could get there by driving, and things would just be on hold, waiting for me to come and render an opinion. Now, even if I do have to operate emergently on a patient, I've already evaluated the situation, I've seen all the data, and all the wheels are rolling. If the patient needs to go to the OR, then the anesthesiologist is taking them there while I drive there, rather than waiting for me to get there and then start the action plan.
Talk about, speaking of driving there, talk about how much you need in your study to do this properly, and whether you can get a reduced version of it in a PDA, or whether you'd have access to it in your car as you're driving in, assuming, right, of course, you're not going to take your eyes off the road and create another, right, medical emergency for everyone.
Well, today there is a hardware control station that's provided by InTouch Health, the makers of the robot. And I have one in my office, that's where I'm talking to you from now, and I have one at home in my study. The same for our intensive care specialist, Paul Vespa. In his office and at home, he can interact with all the ICU patients. In the future, certainly I think it's going to be possible to have this sort of a camera appended to a wirelessly connected laptop, and I don't think it's going to be long before we can depend on the quality of the PDA phones, the smartphones, that are now becoming available in combination with the high-speed cellular networks that also are coming up. The EVDO network that Verizon and Sprint are rolling out has data transfer speeds over 1 megabyte per second. That's going to be enough to allow us to do this kind of interaction right through cell phones, potentially.
Over on the Broadband Wireless Access World sister site of this site, I've interviewed people at Verizon about EVDO and about when it's coming here to Los Angeles, so that fits right in. Talk a little bit, so you're saying that in essence that while you have to be in your study now, in 2 years you ought to be able to do this, but if you've got a cell phone with a big enough screen to access the medical information as well as the video, or maybe, yeah, switch them back and forth.
That's right. That's right.
And not see them at once. You'll be able to do that from wherever you are. Okay, so
that's the goal. Okay, that's the goal. That's what I'm working towards.
Okay, talk about how this provides an impetus to get all medical records digitized sooner rather than later.
Well, the real key, many medical records are digitized, but certainly not all. There are many obvious advantages to having them digitized, and one of the key ones is access to them once they're connected through the internet from anywhere. So just as I can now interact with a patient in the intensive care unit today from home, hopefully in the future when all the other healthcare systems out there are fully digitized, I can consult on a patient in an emergency department in Bakersfield, for instance, who may be having a crisis, maybe having a stroke or having a brain hemorrhage, something that is within my area of expertise, so that as a specialist I can be there immediately and help coach the on-scene emergency room physicians about the appropriate steps to take.
Do you do much of that? Do you do much of that now with the GCQ system, without the video contact?
Well, we still require that the GCQ application be installed at the other facilities, and right now it's only installed at UCLA. In the future, absolutely yes. And with GCQ, I can get the data, I can get the x-rays on my cell phone through Sprint or Verizon networks today. So I've had situations where I was at Dodger Stadium, called about a patient, and I was able to manage the patient through the phone call after having reviewed their brain scans. So we're already beginning to see a little bit of the environment that you're hinting at. But I think in the future, specialists will be able to project their expertise and advice digitally once they get access to the appropriate information.
I want to talk about what's emerging. I did an interview with Yulin Wong yesterday, who's the CEO of the company that makes the robot, and we were talking about, sort of apropos of, Tom Friedman's just written a book called The Earth is Flat, talking about supply chain automation leveling the economic structure of the world. We're essentially talking about a similar process here to make sort of a flat hospital, flat medical practice, so that medical evaluations of x-rays, MRIs, and so on are sent to India or China and evaluated there, and then the data comes back to the U.S. Or to UCLA, and your expertise can now be projected to India or China or Malaysia or Europe, according to the system. Talk a little bit about how you see this robot as a kind of catalyst for that process, and what that means. What's that going to? Obviously, it's a big issue, and it's going to evolve over the next 5, 10, 15 years. But how do you see that process taking place, and what's that going to mean for healthcare overall?
You know, I think we are going to see a leveling, as you say, of the quality of healthcare as the expertise that currently is available only in developed countries becomes more widely available through telecommunications and internet strategies around the world. You know, there are projects right now being initiated in countries in the Middle East and in Asia that involve collaboration and consultation with European and North American specialists. And I think we're going to see that over the next 2 to 4 years really become a reality. I'm looking forward to it. I would love to be able to have a worldwide medical practice.
I'm picturing a painting, I'm not sure exactly what it's called, by Rembrandt, where I think there's it's called In the Surgery or something, or maybe it was another painter, where these doctors are gathered around and they're evaluating the patient and so on. Essentially, we're going to be able to create that on a global scale through telepresence, so that a cardiologist in Italy will be able to be involved, and you'll be able to be involved, and people from all over will be able to bring their expertise to focus on one patient.
Yeah, I think that's all becoming possible now.
I don't want to put... go ahead.
Well, you asked earlier a little bit about the Department of Defense's interest, and it's obvious how this might help. You know, a desirable thing would be to have a cardiac specialist and a neurological specialist available in every forward field hospital. That's not the case today, obviously. They're staffed by medics and general practitioners largely. But in the future, it certainly would be possible through this kind of telecommunication and telepresence for me to assist in the care of a wounded soldier on the battlefield. That would be fantastic.
It's a real mobile Army surgical hospital will be possible, won't it?
Right.
Okay. Just say a little bit about how the structure of paying for that is going to work, and whether the rest of the medical community, the insurers, the hospitals, how they're going to keep up with the changes that are going to be made possible or be precipitated by this kind of flat global medical platform.
Well, you know, that
in 30 seconds.
That element is going to require just as much innovation as the technological developments you see here. That's lagging way behind those concepts. We've just begun to get paid for phone consultations in North America, and they're still talking about what to do about emailing with patients.
That's
so
right.
This kind of thing is a whole new world, really.
So the issue there, because I've tried to get one of my doctors to email me, and she won't. It's either the technical issue or the pay issue or all those kind of liability issues. You're saying all of that exists tenfold with telemedicine.
I think the problem will be dealt with and solved because people want it. People want access to specialist consultations that may not be geographically feasible for them, and when the patients want it in this era of consumerism, we're going to find a way of making it happen.
Talk a little bit about, though, how you are experiencing it already and how you expect you'd experience it if there were 15 or 20 robots available. In other words, it's great that it's going to save you the travel time, but do you have enough bandwidth as a practitioner to treat 20 patients a day in 20 different spots and bring yourself up to date on their medical records and evaluate them and make recommendations? Is there going to be a limit, a critical element there in your ability, even augmented by this technology?
There's no doubt that there's a limit. We can automate all of the communication elements and eliminate the need for travel and automate data display and documentation requirements, but the data assessment and the cognitive processing that a physician has to engage in, still has to be done. So there's absolutely a limit. I could be in 2 places at once maybe, but not 15.
Let me try to push that. What about expert systems to replicate your evaluation and recommendation process?
Well, it may not be that tough to create a computer that does what I do, but there are a lot of doctors out there who are so smart that you're never going to be able to do that.
Okay. So, so you're still going to have to, your time is still, access to you is still going to be rationed, even if it's going to be rationed over a larger population of patients.
Well, certainly, and the patient demand for a meaningful interaction with the physician requires time. They're not going to be satisfied with you appearing on a screen for 30 seconds and blurting out at high speed exactly what's wrong with them and exactly what needs to be done. They need to process it. They need to ask questions. You need to interact on a human basis. That's a key part of medical care.
Right, and those are facilitated but not replaced by this technology. All right.
Absolutely.
Why don't you wrap up by just giving us your overall take on the course of this trial, how long it's going to run, and what you're hoping to learn from it, and what the possible application of what you learn will be going forward.
Sure. Well, we're going to be assessing the technology and the technical integrity and ease of use of the system over the first year, and starting to look at its impact on the quality and efficiency of patient care in the second year. Before it's widely adopted, I think there's going to have to be hard information out there that really makes care better and not just life easier for physicians. And we expect to find that as well. So we're looking very much forward to this exciting new experiment, if you will. But we're confident that bringing the latest cutting-edge technology to the bedside in medicine is exactly what we need today. You know, we're facing a huge crisis in medical care because the demands for medical care will only grow as the baby boomer population ages and gets into that range where they have high demands for health care, and the number of physicians are not going to be able to keep up with it. So we'll have to be more efficient and eliminate the time-wasting steps that fill the whole medical interaction today. This is one step towards that goal.
So you're going to cut out the waste and concentrate on where you actually add value to the process.
Absolutely.
Okay. Well, you've added a lot of value to the process here. I want to thank you for talking to us on Etopia Media Medical News Network, and maybe we'll meet in person someday. Who knows?
I look forward to it. My pleasure.
Thank you very much. Bye.